Math Humans. We're going to do F2 today. We're going to be graphing our logarithms. So our objectives are that we're going to graph the logarithms, and then we're going to find domain and range. We're going to talk about the asymptote or totes, and then we're going to look at our x and y intercepts, and then talk about increasing and decreasing. All of these things we have talked about in the past. So if I have the equation y is equal to the log of x, remember that this is called a common, oops, that's an M, a common log, which means that the base is 10, okay? So if I look at the graph, here would be my axis, okay? And then here's going to be my function. It's going to cross right here at 1. I have a vertical asymptote at x is equal to 0, which is your y-axis. And then everything over here is undefined because you can't take the log of a negative number, okay? So my domain on this one is going to be from 0 to positive infinity. And again, the 0 is not included because it's a vertical asymptote. For the range is going to start at a negative infinity and go to positive infinity. And if you'll remember, we read range from bottom up and we read domain left to right, okay? I have a vertical asymptote at x is equal to 0. There are no horizontal asymptotes, okay? And then my x-intercept is going to be 1, 0. For the y-intercept, there's none because it's never going to cross this vertical asymptote. And then this particular function is increasing, which means that as the x values approach infinity, getting bigger and bigger, the y values are also approaching infinity. They're getting bigger and bigger. And in the past we've said, as x gets bigger, y gets bigger, okay? Or maybe we should say as x goes this way, y gets bigger. So that would be evaluating that particular function. All right, let's do our first example. And we're going to evaluate and sketch. And we're going to evaluate on the same criteria. So we're going to have y is equal to the log base 3 of x. So before we get started, remember that there's two ways to put this in your calculator. If you have the newer calculator, you can do the log base, and you start with the math button, and then log base, and then you would enter your equation. If you're using an older calculator, you could use a change of base formula and write this as the log of x over the log of 3. And I'll show you both ways. So I'm actually going to start with the sketch. So I'm going to go to my handy-dandy grapher. I'm going to clear what's there, and I'm going to go to Math, and then I'm going to go way down to my log base, okay? And this one has a base of 3, and then there's my variable, and I'm going to do a zoom 6, okay? All right, and the graph looks kind of weird. It looks like it's running into the y-axis. If I actually move my cursor right here and do a zoom to enter so you can see it better, it's actually not stopping at the axis. It's what we would call grapher failure. It doesn't have the graphics to show you what's actually happened because it's not a video game. It's just your cute little calculator. So remember that I have a vertical asymptote at x is equal to 0, and even though it's a different base, the function is still going to cross at 1. Okay, and so then I'm going to talk about all of my details. So here's my vertical asymptote. My domain is going to be from 0 to infinity. My range is still a negative infinity to positive infinity. My x-intercept is still going to be 1, 0. My y-intercept, there is, oops, none. And then this one is increasing. Okay, and I think I have filled in all of the information that we would ask. So it's hard to show an asymptote when it's part of the axis. So notice that I just show that it's going to be my actual axis. Okay. All right, I only have a couple more examples for graphing. So let's do our second example. So for example number 2, I'm going to graph y is equal to the log base 7 of x. And just to illustrate a point, I'm going to do this one with a change of base. So I'm going to enter y is equal to the log of x divided by the log of 7 in my calculator. Okay, so if I go back to my y equals, and I'm going to do the log of x divided by, you do have to make sure that you close that second parentheses. If you don't, your calculator will be unhappy. And I'm going to divide by the log of 7, and then I'm going to do a zoom 6. And again, here's my graph. Pretty predictable, a little bit more shallow, okay? It's still going to cross. If I want to see that point, I'm going to do second calculate and my x-intercept, which is a 0. And just to find it, I'm going to go to the left, and then I'm going to cross the axis, enter, enter, and I get that it's still 1, 0, okay? So I'm going to answer all of my questions. I know that I have a vertical asymptote at x is equal to 0, which is right there, okay? I know that my domain is still going to be 0 to positive infinity. The range is negative infinity to positive infinity. The x-intercept is 1, 0. The y-intercept, there's still not 1, okay? And then I have a vertical asymptote at x is equal to 0, and this one is increasing, okay? And sometimes what we write in Math World is that this is increasing over the domain, meaning that the function is increasing for the entire function, and we've already defined our domain, okay? I have one more example for us that's just a wee bit different. And so it's kind of fun to see how the math changes. So we're still going to do the same thing. So I have the y is equal to the log base 5 of x minus 2. Okay? So the cool thing is this x minus 2 is going to cause our graph to change. So in this one, I just want to graph it and then show you what happens. So if I put this in my y equals, I'm going to enter the log, and I'm going to do my change of base. Remember that you can do it the other way if you need to, depending on the age of your calculator, x minus 2, okay? And so then I'm going to hit zoom 6. So notice that things have moved. So let's talk about what happened. This 2 right here moves the graph 2 units to the right, okay? And it's because it's x minus the quantity, okay? So we're not going to go back into translations and talk about it. So this is 1, this is 2, and this is 3. So in the original function, if I had y is equal to the log of x, it would cross right here at 1. But because it moved 2 units to the right, now that means that my x-intercept is at 3. My vertical asymptote was at x is equal to 0, but it's going to move 2 units to the right. So now my vertical asymptote is going to be at x is equal to 2, and this is what my graph is doing. So just so you didn't think that they always stayed the same, sometimes things move. And I'm just going to write down our information that we had. So my domain on this one is going to be 2 to infinity. My range is still negative infinity to positive infinity. My x-intercept on this one is 3, 0. My y-intercept, there's still none. Okay. I have a vertical asymptote at x is equal to 2, and it's still increasing over the domain, but I did have a few things move around, and so that's kind of interesting. All right, my dears, that is it for today. Nice short video. See you soon.